Hello and welcome to the EPRI Current. My name is Samantha Gilman and I'll be your host today. Today we're speaking with EPRI's go-to expert on heat pumps, Ron Domitrovic. He is the Senior Program Manager for Grid Edge Customer Technologies. Ron, welcome to the EPRI Current, and why don't you tell our listeners a little bit about what you do at EPRI?
Thank you, Samantha. It's good to be here. So as you mentioned, I manage the group that's called Grid Edge Customer Technologies, or colloquially named or known as Program 170. It's the program that evaluates and understands the nature of evolving end-use technologies, so things that use electricity. And one of the major components, or one of the major users of electricity, are thermal systems like air conditioning and water heating. And that's becoming a very important topic as we try to decarbonize fossil heating throughout the country and really the world.
So, as we hear these discussions around decarbonization, the U.S. decarbonization goals for 2030, 2050, a big part of that is the decarbonization of the built environment. And a topic I keep hearing around that is the use of heat pumps and changing out the existing gas furnaces or whatever you might have as your HVAC for a heat pump. Why is that the conversation we're having?
Well, it's the conversation because a heat pump allows you to provide heating to a space or to water or to a process or something like that using electricity. And then if you can get that electricity originally from a renewable source, it effectively allows you to heat your buildings or your water or whatever fully with renewable energy. But then there's an added benefit that a heat pump inherently, because it's a cycle, and I won't go into the depths of that, but because it's a cycle, it can act very efficiently, meaning that for each unit of power you put into the machine, you can move a lot more heat. And you can get these ratios of 3, 4, 5, even 6 to 1. So for each unit of energy you put in, you can move and provide heating on, with a 3, 4, or 5, or 6 times multiplier. And so that's where the efficiency of the heat pump comes in. So it's really those two things. One, it allows you to use electricity, which can ultimately be renewable. And two, it does so in a very efficient way.
So before we really launch into this conversation, why don't we give a bit of a primer for our listeners? And can you tell us what exactly is a heat pump? Don't get too technical. Tell us what a heat pump is. I don't need to know all the ins and outs, but essentially, what is a heat pump?
Sure. So a heat pump is the inverse, really, of a power generation cycle. And so what's a cycle? So we can go layers and layers deeper. But so most should be familiar with burning a fossil fuel. So if you have a gas furnace or a gas oven or something like that, you are burning a fossil fuel in a process. You light that fossil fuel, it combusts chemically, and it releases heat as it does that. That's just a process. It happens, and then you get end products, and then it's done, and you can take the heat out. A heat pump is different in that it's a cycle, in that you use a fluid to flow through a set of processes so that you can move heat from a cold place and deliver it to a warmer place through the input of power. And so you use a motor-driven system typically to compress a fluid to circulate through a machine that has these 4 different sort of processes going on that allows you to move heat from one place into another place, sort of against the natural flow. So normally we're familiar with heat wanting to flow from hot to cold. A heat pump allows you to move heat from cold to hot with the, by using the input of energy to allow that to happen. So that's in its essence what it is. It's simply really is a pump. It's taking heat from a cold place and moving it to a hot place, kind of against its natural propensity.
Got it. Yes, I do hear this a lot as we talk about electrification. I know at EPRI's Electrification 2024 next March, heat pumps is a big topic. And the comparison I want to make is, we're starting to use EVs now. So instead of burning a fuel to run your car, you're using electricity to run your car. Similar for a heat pump, instead of using, say, natural gas in your gas furnace to create heat, you're using electricity to create heat. And as we decarbonize the electric sector, bringing in more renewables, hydro, whatever it might be, we are decarbonizing there, allowing us to electrify here and overall reducing emissions. We are entering the winter months and it is getting colder. And I, through my time of EPRI, have heard about heat pumps in cold weather. It's, that has been tricky in the past. So can you tell our listeners about um, heat pump performance in cold weather and how it's getting better and what challenges may lay ahead?
Sure. Yeah. And so I'll go back a little bit even to what I was describing in the beginning, the process versus the cycle. So go back to the gas furnace. A gas furnace is effectively independent of temperature. And so, whether it's 30 degrees outside or minus 10 degrees outside, the furnace doesn't care. The combustion effectively takes place the same way and you get the same amount of heat out. And so you simply have to size a furnace for the worst condition. So if you say, okay, the worst, coldest it's ever been is 10 below zero, then you size a furnace accordingly and it will cover you for that need. Well, a heat pump is a little different. And again, it's because it's a thermodynamic cycle that the efficiency and the ability to move heat, the ability to pump that heat, is dependent on the temperatures at which the system operates. And so it's dependent on the actual temperatures. So if it's 10 degrees outside or 5 degrees outside, it's dependent on that. But it's also dependent on the difference in temperature from where you're coming from to where you're going to. So if you're trying to take heat from 10 degrees outside and pump it up to be 90 degrees inside, then that's more difficult than if it's a lower lift. And we call that the temperature lift. And so the heat pump performance is dependent on that, very much so, which is completely different from how a combustion works, a fossil combustion works. And so it's critical that you design a heat pump accordingly. So a bit more sort of design care has to be given to figuring out which heat pump style and size and so forth and system is used in a particular building in a particular climate. And that's part of the difficulty of using heat pumps. I wouldn't say difficulty. I mean, a skilled engineer knows how to do that, but it's given that heat pumps are proliferating so much and are becoming such an important part. I think that's a poorly understood part of the equation, is that they require some care in understanding how to apply them. Now, to your question about how they perform in cold climates, so you do different things and you design systems slightly differently if you know you're going to be in an extremely cold climate. So, well, what's extreme? So a typical heat pump for, let's say, a residence is well suited to handle temperatures down to 15 degrees, let's say. But if you know you're going to be minus 15 because you're in the northern tier of the United States, well, then you might want a slightly different system that has different operation that allows you to have adequate heating capacity down in those lower temperature ranges. Likewise, I should say, if you're in a different building style, so let's say it's not a residence where you're blowing hot air, but it's a tall building where you're circulating hot water. Well, that hot water needs to be relatively warm in the range of 140 to 160 degrees. So that increases the lift as well. And so you have to have a slightly different system designed very specifically for that situation. So heat pumps are very effective, but care has to be taken into how to design them and how to deploy them. Does that help?
It does. And something I've been wondering as part of this heat pump discussion is, can heat pumps also make it cold? Do heat pumps replace air conditioners?
Yeah. So, effectively, yes. I mean, a heat pump is the heat pump is the larger set, and air conditioner is a subset of a heat pump. And so a heat pump is just a device that takes heat from a cold location and pumps it into a warm location. So which side do you want to use? That determines whether you're using it as a heating heat pump or a cooling heat pump. So in the summertime, you are using a heat pump to cool your house. You're simply taking air out of a colder place, or you're taking heat out of a colder place, which is the inside of your house, and you're pumping it up to the outside, which is warmer. In the wintertime, you're doing the opposite. You're taking heat from a colder place, which is the outside, and you're pumping it up and delivering it to the inside. So that's accommodated with valving and so forth that switches the flow of refrigerant. But yes, they are effectively the same thing. It just depends on which side of the equation you want to, whether you want to use the cold side or the hot side. Now, but that brings me to something that in the very best situations, you can use both. So heat pump water heating is often good at doing that because you need heating for the water. So you take the hot side and you deliver it to the water. But if it's in the summertime, you might use the cold side to partially condition your house. So that's why heat pump water heater in the summertime is actually a very good thing, and why those types of devices are extraordinarily efficient in places in warm climates like Florida, Hawaii, etc. Because you get both sides of the equation and you get extraordinarily high efficiencies. You can get efficiencies on the order of 8, where for each unit of energy you put in, you're getting 8 units of either heating or cooling.
So how are we seeing the adoption of heat pumps currently, and what trend have you been seeing over time, and what are we anticipating moving forward?
Well, I think the trend is certainly increasing. I think the stat is that there were more heat pumps sold last year than gas furnaces for the first time ever in the United States. In the southern climates, so let's say Tennessee and below in the southeast, heat pumps are relatively common. I think in Tennessee, something like 40% of households are heated with a heat pump, and so they're fairly common, and they're becoming more common slowly into the northern latitudes. However, there is a transition going on in the technology. And this would go a little deeper into the weeds. Maybe we have another podcast that goes deeper into the thermo. But the traditional style of residential heat pump, at least, is what's called a single-speed heat pump. And it's effectively, it's the thing that most of us have at our houses. And it's supplemented with electric resistance heat to accommodate the very cold occasions. That technology is slowly being replaced by what we term variable capacity heat pumps or variable speed compressors. And in such a way that in many cases, the secondary electric resistance heat can be eliminated. And that's actually the goal. You would prefer to have a system that is entirely heat pump that does not need to have that secondary heat, even for the coldest days. And so that's the technical transition that we're seeing happening currently.
So speaking of continuing on the conversation of adoption, one thing I've thought about heat pumps, I've thought about getting one myself, but it's tough to just get a new heating unit, a heat pump in place of a gas furnace, when you don't necessarily need one. And I'm going to guess that has been a hurdle for adoption, but are electric companies doing anything to support the adoption of heat pumps, maybe to help with that issue? Because I can't be the only consumer out there having that issue.
Yeah, no, you're right. It is a concern. I mean, and it's difficult if you're often buying a new heating system when your old one fails. And so you're kind of at the mercy of the first contractor that shows up and whatever they have available. So you say, yeah, just put it in. I need heat. And so a couple of things. We're trying to educate the consumer as much as possible about the options. But to your question, yes, absolutely. The utilities probably play the most important role in educating and offering and incentivizing efficient and environmentally responsible methods of heating. They absolutely, encourage the use of efficient systems, and in many cases, in a growing way, are incentivizing the use of decarbonizing solutions, which would be the heat pump. Now, there are some regulations that prohibit, in certain circumstances, the incentivized switching from natural gas to electricity, but that's actually changing. We see that changing in certain states and many parts of the country, to where decarbonization is something that can be promoted through utility programs.
Thanks, Ron. As we continue to discuss decarbonization over the coming days, months, years, it's good that we explore all these different pieces of that decarbonization strategy as we decarbonize the electric sector, the built environment, transportation. There are many pieces to this puzzle, and heat pumps is just one of them. And I'm glad we were able to explore the topic and share with our listeners. That's it for today. I hope you enjoyed this episode of the EPRI Current, and we'll catch you next time.
If you like today's show, we invite you to subscribe to our podcast. And feel free to share the podcast with your colleagues and friends. For more information about EPRI, please visit our website at www.epri.com. And don't forget to follow us on LinkedIn and Twitter at EPRI News. Together, we are shaping the future of energy.